So we are going to start February-March 2020, paper 2-2. Question number 1. Figure 1.1 shows how the first ionization energy vary across period 2. Construct an equation to represent the first ionization energy of oxygen, include state symbols. So whenever we have to write the first ionization energy of any element, we write its atom in a gaseous state. Then after arrow, we would write its +1 charge gaseous ion and then an electron. That is how we would write the ionic first ionization energy. Okay. They are asking state and explain the general trend in first ionization energy across the period. So if you see, this is the period 2. Okay. Starting from lithium, this is your period 2. Okay. Starting from lithium and ending at neon, it's from group 1, group 2, group 3, basically group 13, group 14, group 15, 16, 17, and 18, right? So if you observe the general trend from here till here, the general trend is that the ionization energy is actually increasing. So as they ask state, so first we would state this, that ionization energy increases across period 2. Now we have to explain it, the reason. So I can write that across period, there is increase in nuclear charge and the electrons are being added in same shell. So the nuclear forces of attraction nucleus and valence electron increases. Is clear to everyone?
सर हम ये
Yes.
कह सकते हैं कि चार्ज डेंसिटी इंक्रीज होगी.
Yes. Here I said that the increase in nuclear charge. Instead, this statement you can write that there is a charge density. You can write that as well. Okay.
ओके सर.
And one more thing. Here I have written that the electrons are being added in the same shell. Instead, this you can, or you may write that the shielding effect remains same. Now, next part. Explain why ionization energy A in figure 1.1 does not follow the general trend in the first ionization energies across the period 2. Okay, let's see where is energy A. Okay, so if you recall, the atomic number of nitrogen is 7 and the atomic number of oxygen is 8, right? So if you further recall, the valence shell electronic configuration of nitrogen is 2s2 and 2p3, and here it is 2s2 and 2p4. So in P of nitrogen, there are all singly filled electrons in each of the orbital. But here it's TP4 where the P orbitals, if you fill the 4 electrons, one orbital have a pair of electron, and due to this pair of electron, there is a spin pair repulsion, and due to which the electron gets further away. And that's why there is a decrease in ionization energy from nitrogen to oxygen. Is this understandable? Yes, if anyone have any confusion, do ask. Okay. So I can write that ionization energy A gets lower as one p orbital has pair of electron which causes spin repulsion hence the electrons get further away from the nucleus. Is this understandable?
Yes sir.
Okay. Now C part. Element E is in period 3 of the periodic table. Okay. The first 8 ionization energy values of E are shown in table 1.1. Okay. Use the full electronic configuration of E. Explain your answer. Okay. If it is in period 3, then it means that it have a 3 shells. Is this understandable to everyone? Yes.
Yes, sir.
Okay. Now, if you look at these difference, see over here. Here the difference is around, I think, 1200 or 1300. Here the difference is around 900. But if you see, here the difference is around 9000, right? So this big energy gap actually tells us that their shell changes. So it means that these three belongs to valence shell. Hence, we can further say that three electrons in valence shell, and the valence shell is the third shell. Is this clear to everyone? Yes.
Yes, sir.
Okay. Now start writing the electronic configuration. First shell, 1s, 2 electrons. Second shell, 2s, 2 electrons. 2p, 6 electrons. Now third shell, and in third shell I have to just fill 3 electrons only. So in third shell, first s have a 1 electron. Sorry, s have a 2 electrons. 1 electron is left. So 3p1. So this is the complete or full electronic configuration of E. Is this clear to everyone?
नहीं सर, इसमें आपको एग्जैक्ट नंबर ऑफ इलेक्ट्रॉन्स ऐसे पता चलेगा?
देखें, this is the nucleus, right? This is the first shell. This is the second shell. This is the third shell, right?
जी
If this electron is being knocked out, we just need 577 kilojoules energy, right? When this
जी
electron is knocked out, the charge gets relatively greater. And when I have to remove the next electron, I need a little more energy. So to remove the next electron, I need this amount of energy. Is this clear? Now the charge even get relatively more bigger. And when I have to remove this electron, I need this amount of energy. Is this understandable?
यस
Now the charge even gets more bigger, right?
जी
So if you observe the trend, if the next electron is in this shell, then the next amount of energy that is needed to remove the electron must be 3600 or 3800, like this, right? Yes, Abdullah.
अच्छा सही समझ गया होगा.
But here the energy to remove the next electron is 11,600, which is clearly indicating that this electron is actually removed from the inner shell, and due to the charge gets bigger, and beside that charge getting bigger, the electron is actually come closer to the nucleus. So there will be a more stronger forces of attraction that would lead to that much amount of energy is needed to remove that electron. Is this clear?
Yes, sir.
Okay. Now explanation. I can write that there is a big energy gap between third and fourth ionization energies. Hence, valence shell have three electrons. Yes, is this clear to everyone?
यस सर सर आप इससे पहले वाला एक मिनट क्वेश्चन दिखा सकते हैं? सही है.
Okay. Now let's move to the next part. Okay, the first question is ended. Now we are going to start question number 2. Some oxides of elements in period 3 are shown. Okay. We have sodium oxide, aluminum oxide, phosphorus oxides. There are 2 phosphorus oxides and 2 sulfur oxides. Sodium reacts with oxygen to form Na2O. Na is the reducing agent in this reaction. So, if I write the equation, the reaction would be like this. So to balance the equation, I have to put a half over here and 2 over here. If you place the oxidation numbers, its oxidation number is 0 on the reactant side because both are element. And here we have a compound whose oxidation number is 0. Oxygen is -2 and sodium is +1, and there are 2 sodiums make it +2. That's why the net charge is 0. Is this understandable to everyone?
Yes.
Okay. So if you see over here, that sodium is changing from +1 to, sorry, 0 to +1. So if its oxidation number is changing from 0 to +1, which is indicating that it is losing an electron, right? And if it's losing an electron, so it means it is undergoing oxidation. And if it's an undergoing oxidation, then that's why we call it a reducing agent. Is this clear?
Yes, sir.
So we can write
Yes.
सर तो Na खुद रिड्यूस हो रहा है या ऑक्सीडाइज हो रहा है?
Na itself undergoing oxidation. That's why it is reducing agent.
ओह ओके सर, समझ गई.
Reducing agent loses its electron
सर हम इंक्रीज इन ऑक्सीडेशन स्टेट लिख सकते हैं?
it's better to write in terms of electrons.
ओके सर.
Yeah, you can write that as well, but it's better to write in terms of electron. Is this clear to everyone?
Yes.
Okay. Write an equation for the reaction of Na2O with water. So let me recall you, whenever there is a metal oxide and it reacts with water, you will always get metal hydroxide. It's simple. Metal oxide reacts with metal water to give metal hydroxide. This can be a general equation for a group 1. But if the metal, okay, it's M2O for group 1. If it's a metal oxide of a group 2, then it would be a MO. M is replaced by the symbol of a metal. When it reacts with water, then we will get a metal hydroxide of this formula. So this is the general equation for the group 2 metal oxides, and this would be the general equation for the group 1 metal oxides. So here we have a sodium. So Na2O reacts with water to give you NaOH. To balance the equation, I have to put 2 over here. Yeah, 2. So here must be a 2. Is this clear? Aluminium oxide is an amphoteric oxide found in bauxite. State what is meant by the term amphoteric. So,
Can act like a base and an acid.
yeah, good. Amphoteric means that act like an acid or base. Not or, sorry, and base. Or you can write that it can react with an acid and a base as well. Is this clear?
Yes.
Aluminium oxide is purified from bauxite in several steps. The first step involves heating aluminium oxide with the excess NaOH, a colorless solution forms. Write an equation for this reaction. Okay, so that's what the reaction that we have observed and that we have discussed in, I think, in period 3 as well. You would find the equation if you look at in the notes of period 3. There is an aluminium oxide. It is reacting with sodium hydroxide, but see, we are reacting with aqueous sodium hydroxide, right? And we would be heating it as well. So it means that it would react with water as well. And as a result, we will get a salt, sodium aluminate, and AlOH4. Now, if you have to balance the equation, there are 2 aluminiums over here, so you would put 2 over here. By putting this 2 makes the sodium on the product side 2, so I would put 2 over here. Now, this 2 also makes the hydrogen 8. So I would put, sorry, 2 hydrogens are over here with the NaOH, so 6 were left, so I would put 3 over here. Now my equation is balanced. Is this clear to everyone?
सर आप ये H2O वाला जो आपने बैलेंस किया है वो फिर से रिपीट कर सकते हैं?
Balancing?
जी सर.
Okay. See. Here, how many aluminiums are here? So I can put 2 over here. That makes these aluminium 2 as well. Now by putting this 2, the Na also become 2. So I would put 2 over here. Is this clear?
Yes, sir.
This 2 makes the oxygen 8 and hydrogen 8 as well, right?
जी sir.
Here I already put a 2 and have a 2 hydrogens, right?
जी sir.
So 6 hydrogens are left to balance. So I would put 3 over here. This makes these hydrogen 6. So 6 plus 2, 8 hydrogens over here. Now, if you count oxygens, there are 3 oxygen over here. There are 2 oxygen over here. And there are 3 oxygen over here. So this 3, this 2, and this 3 gives you 8.
8. Okay sir, समझ आ गया.
So now the equation is balanced. Okay. Aluminium oxide used as a catalyst in the dehydration of alcohols. Okay. State the effect of using aluminium oxide as a catalyst in the dehydration of alcohol. Use the Boltzmann distribution figure 2.1 to help explain your answer. Okay. So how would we do? First, we would put a one
So the
vertical line.
activation energy decreases.
Yes. And then I would write EA, that is the activation energy. And then I would put another line at a lower energy. And here I would write CEACAT, which is actually suggesting that it is a activation energy when the catalyst is added. So see. So what happens by adding the catalyst? Catalyst lowers activation energy. And what happens by lowering the activation energy?
Number of successful collision increase.
Why? See, initially, this proportion of the molecules are undergoing successful collisions, right? But when we, added the catalyst, now this proportion of the molecule undergoes successful collisions. So first what we would write, that
लेकिन
catalyst
सर
lowers the activation energy. Yes.
कैटलिस्ट तो मतलब रेट पे तो कोई इफेक्ट नहीं लाता था ना, सिर्फ स्पीड पे.
So what is the difference in rate and speed, Abdullah? Catalyst doesn't affect the equilibrium position. You are mixing two things. Catalyst always speeds up the rate. Catalyst always increases the rate. Catalyst doesn't affect the position of the equilibrium.
सही है.
So catalyst lowers activation energy.
सर ये ग्राफ का शेप चेंज नहीं होगा, थोड़ा सा आगे की तरफ नहीं जाएगा?
No, it happens by when we change the temperature. We didn't change the temperature. We just put it the catalyst, so the barrier for the molecules to react would be that one initially. And
Sir,
when we added the
catalyst से
catalyst,
ओके सर.
rate of reaction तो increase होगा ना?
yes, it increases. So catalyst lowers the activation energy. Now we are observing in the graph that more proportion of
Sir, alternative path पे लिखना जरूरी नहीं है?
no, here there is no need.
Okay.
More proportion of molecules having energy equal to and the activation energy which leads to increase in frequency of successful collisions. Is this understandable to everyone?
सर ये आपने जो एनर्जी ग्रेटर देन इक्वल टू एनर्जी एक्टिवेशन एनर्जी लिखा है ना, तो एक्टिवेशन एनर्जी ऑफ कैटलिस्ट होगा ना?
No, it doesn't matter now because we already stated that the catalyst lowers the activation energy. So it means right now when we are talking about this, it is understood that we are talking about now the lower activation energy. You can write this way as well, but it is not mandatory. And we, instead writing frequency of collision, we write increase in the frequency of successful collisions. That is important. Is this clear to everyone?
यस सर.
Okay. P4O6 is a white solid that has a melting point of 24 degrees Celsius. Low melting point, right? Solid P4O6 reacts with water to form H3PO3. Reduce the type of structure and bonding shown by P4O6. If it is reacting with water, yes, very good, Sana. There is a covalent bonding. From this, we can conclude because ionic doesn't react with water. Normally, ionic ionizes in water. And low melting point telling us that its structure is simple molecular.
सर मुझे पूछना था सर, लाइक फॉस्फोरस ग्रुप 5 में है तो इसे सिर्फ 3 इलेक्ट्रॉन्स चाहिए अपना शेल कंप्लीट करने के लिए, पर यहाँ पे ऑक्सीजन मतलब इनका रेशियो मुझे समझ नहीं आ रहा है.
If you recall, we have done one example of PCl5 as well in our chapter of bonding, because phosphorus have a empty 3D, so it can undergo extended octet.
सर तो पीरियड 2 के अलावा सारे extended octet में जा सकते हैं.
Yes, in period 3, the covalent substances, the elements which are in period 3 can undergo, in their extended octet state, where they have a more than 8 electrons in their outermost shell. Okay.
जी sir.
So from these two observations, we can conclude that, and now we will write that P4O6 is simple molecular as its melting point is low and then there is covalent bonding in P4O6 as it reacts with water. Is this clear to everyone? Determine the oxidation number of P in H3PO3.
+3.
+3. Yes, very good. So if we work it out, the net charge is 0. Hydrogen is +1. There are 3 hydrogen, makes it +3. Oxygen is -2. And there are 3 oxygen, makes it -6. And we get a net charge of 0. So here, there must be a +3. So the oxidation number of phosphorus is +3. Okay. When P4O6 is heated with oxygen, it forms P4O10. The enthalpy change of formation of P4O10 is minus 3012. See, it's a formation. And the enthalpy change for this reaction is given over here. They are asking you to calculate the enthalpy change of formation of P4O6. Okay. So, when we talk about formation, the formation is the one where uh, 1 mole of a compound is being formed from its elements, right? So, I would make a Hess cycle over here. So, it would be easy for you. P4O6 is reacting with 2 moles of oxygen, forming P4O10.
सर हैश साइकिल का सिर्फ 1 मार्क तो आता है.
Sorry. Normally it comes for 2
हैश साइकिल का
marks.
क्वेश्चन सर.
No, mostly it comes for 2 or 3 marks. I don't know why they have given you this time 1 mark, but it's very easy.
सर इन्होंने ज़्यादा इन्फॉर्मेशन दे दी ना, इसलिए वो एक मार्क्स दे रहे हैं.
Yes. So, see, this reaction have this enthalpy change. This reaction has this enthalpy change because here P4O10 is forming from its elements, right? And these, when form this P4O6, that's we have to find it, that is X. So if you look at the cycle, we can easily conclude that this is my direct route, and from here till here is indirect route. So it would be X plus minus 1372 is equals to minus 3012. So X would be equal to minus 3012 plus 1372. So tell me the answer, please. See, it's very easy. That's why I think they have given me for 1 mark. Yes, can anybody tell me the answer?
minus 1640.
Minus 1640 kilojoules per mole. Okay. Now, write an equation for the reaction of P4O10 with water. It's a non-metal oxide which is acidic, and you would find this equation. Yes,
Phosphoric acid.
you would find, yes, phosphoric acid. Find this equation in the period 3 notes, that when P4O10 reacts with water, it would form phosphoric acid, which is H3PO4. Now I have to balance the equation. We have 4 phosphorus over here, so I would put a 4 over here. This 4 makes these hydrogen 12, so I would put a 6 over here, and I think my equation is balanced now. Yeah, it's balanced now.
That stage
You can check. They didn't ask for the state, so there is no need to write the state.
Okay, sir.
SO2 and SO3 are found in atmosphere. The oxidation of SO2 into SO3 in the atmosphere is catalyzed by NO2. So it's a catalyst. The first step of the catalytic oxidation is shown in equation 1. Construct an equation to show how NO2 is regenerated in the catalytic oxidation of SO2. Yes, if you recall it from the notes, as NO is formed, it quickly reacts with the oxygen and regenerated as NO2. Then NO2 can also react with unburned hydrocarbons to form photochemical smoke. State the product of this reaction that contributes to photochemical smoke. Okay, so if you recall, we have discussed in the nitrogen and sulfur chapter that these unburned hydrocarbons and NO2 join or bonds or reacts with each other in the presence of sunlight, where they are going to form another kind of compounds that we call it PAN, or the full form is peroxyacetyl nitrate, which actually causes smoke. Is this clear? Let me write over here. It is peroxy.
सर आपने पीरियड 3 वाला पीडीएफ शेयर करा हुआ है?
I think so, otherwise I would do it.
Okay, sir.
Okay. Then have a look over here. Figure 2.2 shows how the temperature of atmosphere varies with the height from the ground. Okay. The equilibrium reaction in equation 1 has an enthalpy change of 168. Okay. This one. Its enthalpy change is 168 with minus 168, which means it's an exothermic reaction. Right? Let me write the equation over here. It is SO2 reacting with NO2 and a reversible reaction forming SO3, and this is how the equilibrium differs at a height of 20 kilometer compared with the height of 50 kilometer from the ground. Okay, so at 50 kilometer height, if you see, the temperature is around 0, right? So I can write over here at 50 kilometer, the temperature is lower. And now let's have a look at the height of 20. If you look at the height of 20, the temperature is quite high. So what happened to the position of equilibrium when I compare these two heights? When I compare the 50 kilometer height with the 20 kilometer height, so with respect to 50 kilometer height at 20 kilometer, where the position of equilibrium changes?
sir, -60 टेम्परेचर कम नहीं होगा?
Yeah, sorry, it's even more lower. So right now, relatively, I can call it this is a greater temperature and this one is a lower temperature. So at 20 kilometer, where the equilibrium position shifts. Okay, just let me know if you remember the rule. If we lower the temperature, where the position of equilibrium shifts?
Exothermic.
Exothermic. So our forward reaction is exothermic. So it means equilibrium shifts towards right. Okay, good. So at 20 kilometer height, the temperature is lower than at 50 kilometer height. So the position of equilibrium shifts to the right because forward reaction is
सर वो लेफ्ट पे मूव नहीं होगा?
y. At 20 kilometer height, the temperature is lower
जी सर.
and it's a exothermic reaction, which means the forward reaction is exothermic. And at lower temperature, the equilibrium shifts towards the exothermic side, right?
जी सर.
So the forward reaction is exothermic. That's why the equilibrium shifts towards the right. Is this clear to everyone? Yes. Is this clear to everyone?
Yes, sir.
Okay. So we were ending the class over here, and tomorrow, inshallah, let's see, we will continue. We will resume this paper and start doing. Okay, here we have ended the question number 2. Now question number 3. Okay, we will start with question number 3 in the next session. Okay.
सर
Okay,
ये जो
take care, everyone.
ऑर्गेनिक केमिस्ट्री
Yes.
में कार्बोनिल और अल्कोहल के अलग से भी इक्वेशंस और रिएक्शंस हैं, वो भी सारी मतलब याद करनी होती हैं?
Yes.
मतलब उसमें reagents
Yes,
भी?
everything that is in the reagents and conditions and the type of that is
सही है.
taking place, we have to uh, remember all these.
अच्छा सर, जो आपने ऑर्गेनिक केमिस्ट्री के बाद जो चैप्टर्स कराए उनके प्लीज पीडीएफ्स भेज दें ग्रुप पे.
Okay, sure. Okay.
थैंक यू सर.
Okay, take care, everyone. Allah Hafiz.
अल्लाह हाफिज़ सर.
Hafiz.